Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're back on, guess what? The Apple Lisa. This video is going to be part 7, if I recall. So if you haven't watched the previous parts, I really do recommend you do. I created a playlist in case you want to really catch up. As usual, I'll have links to all the different parts down in the description below as well. So since this series is so long, it's getting hard to recap, but I'll do a really quick recap. The Apple Lisa, which you see running, parts of it running on the bench here, was given to me by a friend of the channel, AJ, and the machine was in really rough shape. It originally came from Germany, and the battery had leaked inside and had caused tons and tons of damage. And getting to this point now, where the machine is actually booting, now it's booting off a floppy disk, so it's trying to install to a hard drive, which doesn't exist, so it's kind of running. This has been a very long process. The machine as it sits today is a combination of various parts. Some of them are original from the machine I got from AJ. Then the power supply and the motherboard are parts that I got from Alex the cat. Alex is the person that has re-engineered or recreated the PCBs for the motherboard and the I/O board, the two things that are most often damaged on the Lisa 1 and the Lisa 2. The I/O board, which is the board you see facing the camera, that was donated to the channel by Jared, who sent in a bunch of Lisa parts from Barn Find Lisa 210. This I/O board, though, was damaged. It was vandalized at some point, so in a previous part, I completely rebuilt that, got that up and running. Where we left off in the last video, I had just got the machine actually booting into the operating system, which is exactly this point we're at right here. And in today's video, what I'd like to do is try to go a step further and actually boot a full running LOS Lisa Office system on this machine. And to do that, I need a hard drive, and I do have a hard drive emulator. It plugs into the parallel port. But I also have one of these. This is an Apple profile drive, and on a recent second channel video, I did some diagnostics and testing on this drive to make sure that it works, and it does seem to work. And I loaded a fresh copy of LOS 2 onto this drive, and it's the version that's not serialized, because there is kind of a DRM on these machines. So this drive should technically boot this machine, and we can actually see a full working Lisa OS, not just this error message, which is all I get right now. There are a few things I want to do before I actually boot the hard drive image though, and that's try to fix the audio, which isn't working, and the power light, which isn't working on this machine. So without further ado, let's finally get right to it. Okay, well, lots to do with this video, and I have lots of updates I want to give before we even get started. So besides that profile hard drive, which I worked on in a recent second channel video, you'll notice that a large floppy drive is sitting on the bench, and this is not the normal 800K drive that I have been using and testing with on this machine. This is actually an Apple 400K single-sided floppy drive. The Lisa is currently loaded up into LOS Disk 1 off of this floppy drive. So this drive is totally working. In fact, if we hit cancel, what's going to happen is it's going to eject this disk after a little while. It does some stuff, I guess, and then the disk will eject. The original drive that was in this machine, I can tell you, did not work properly. It was gummed up and had some other issues. There's the disk. So the drive you see mounted inside the chassis that will go back inside the original Lisa is a result of work I did in a second channel video, which I think by the time this video comes out, the video on the disk drive will already be out. So I'm not going to talk too much about the process I went through to get to where this drive is here, because it's all going to be in that second channel video, which is rather long, because anytime you work on floppy drives, let me tell you, it's a pain in the butt. Needless to say, this is a working 400K floppy drive, which is awesome. And if I pop this disk in here and I hit the button here, it will boot up back into that error screen that we saw before. Okay, one more quick update before we get to the repairs of the sound and the power light is you may be noticing I don't have that D-sub connector sticking through the plate anymore that was for the RGB to HDMI. The RGB to HDMI display you see on the screen is actually coming from the composite video jack. When I first tried the composite video jack with the RGB to HDMI in whichever part that was, I don't remember, the picture was rolling and I couldn't get the sync working. So I ended up clipping directly onto the little bus transceiver chip back there on the motherboard that allowed me to pick up the digital signals directly. The little D-sub connection I had in the last video was just those digital signals brought out so I could plug it in externally. Well, after talking with Ian, who maintains the RGB2HDMI project, he gave me some tips on how to configure the profile for the analog output on the Lisa. And it turns out that while there was a profile for the Lisa already there, it was actually created by Ian just based off some timing information he saw from the digital profiles that other people had created. Ian doesn't have access to a Lisa himself, so this was untested. Needless to say, the composite video RGB HDMI profile that works, this one you see here, has been sent over to Ian and will be included in future releases of the software for the RGB to HDMI. So know that if you have a Lisa you're trying to troubleshoot, say you might suspect it's got CRT or video problems, but it maybe is booting otherwise, plugging into the composite video jack is a great way to do troubleshooting because, of course, on a real Lisa, there's interlock switches that prevent it from running while the case is open. And this just allows you to plug in a single RCA cable and get pixel perfect display out of an RGB to HDMI without having to get any other special adapters or cables or wire it directly up to the motherboard like I did. So with the D-sub connector that I removed, there's a little piece of wire that's just tucked down here. I zip tied it together. So if I ever want to reconnect another D-sub connector for a digital RGB HDMI connection, I can do so. But really, there's just no need because I have the RCA jack. And I think that brings us all up to date on all the things that's going on with this Lisa. So what should we attack first? Let's try to figure out what's going on with the sound. Last time I had this speaker hooked up, and I suspected it was the speaker, but it's actually not, I heard the beeping just faintly out of the speaker, but I didn't hear the normal beeping that you should hear out of the Lisa, say if there's a diagnostic error, like that original error 57 I was getting with the floppy drive controller. So here's the Lisa I/O board. I know for a fact the audio amplification circuit is over in this area. So I have a feeling the problem exists here because when I did have the speaker hooked up, I could just faintly hear the sound. So the sound's actually getting through to this board. The issue exists in the amplification circuit. Now remember, this board was originally given to me by Jared and it was vandalized. I think this one was actually from a Lisa that was in a school. And since the I/O board is the board you can see when you pop the cover off the Lisa, I think some kids or some vandals basically did a bunch of damage to the board, like trying to pry chips out and wrecked a bunch of things. So in one of the previous parts of the series, I went and I replaced all the damaged and missing parts from photos and looking at the other I/O board because they're largely the same. The battery damaged one from the 510 has some differences because it supported batteries. It had a battery charging circuit and it didn't use the integrated WAS machine for the disk controller, so that part's different as well. For the most part, they are very similar. I did a lot of the comparison between the damaged board and this one just with a visual inspection. So it's quite possible that I missed stuff, and maybe that's why the audio section is just not working properly. The other possibility, of course, is that some of the components I transferred onto this board came from the battery damaged board, and even though that went through the sonic cleaner, maybe those parts are bad. I tried to test everything I put on this board before I transferred it over, but it's quite possible that some components that were bad snuck through. So let's find the amplifier section on the schematics. These are the schematics specifically for this board. So it appears that we actually have two inputs into the audio amplifier section. Their speaker in comes from the main connector that goes down to the motherboard. That's J1. And there's also another section of the board that generates tones. So I suppose the Lisa maybe has a digital sound capability, but also a beep speaker kind of thing. I'm curious. Let's take a look at page 2. This would be where that tone comes from. And there it is right there. It comes right off one of the 6522s. So absolutely, you can program one of these outputs with a timer to create like a beep speaker kind of a thing. Now, what I'm not positive about is when I had the error tone, when the thing wouldn't pass its diagnostics, if that was being generated as a tone from the 6522, or that was this speaker in signal. Either way, the parts of the circuit that are relevant, there's an 74S112, we have another gate, then we have transistor Q5, we have two TL074 op amps, there's one there, one there. The speaker input coming from the other board feeds into the second stage. This is actually the same IC. It's U10A, but there's going to be 2 units inside of that, or 2, maybe there's 4 actually, but at least 2 units. And the output stage are these 2 transistors that I did definitely take from the battery damaged board. I'm not sure which other components I took from it, but without a doubt, those 2 components did come from the other board. There's a 10 microfarad 16 volt cap on both the negative 12 volt rail and on the positive 12 volt rail just to give some oomph to those rails for the amplification. And if you recall, when I rebuilt this I/O board and repaired all of the vandalism that had happened to it, the caps were all replaced with 220 microfarad caps, at least these axial caps, because I didn't have any 10 microfarad caps to install. These are the two caps specifically, C9, C21. Here's Q5, Q4, and Q3. And there is the TL074 op-amp chip. So this absolutely is the entire amplification circuit all in one little area. Now, one thing I'm noticing by just looking at this, there's a missing resistor, R11, and the cap kind of obscures it, especially when I look down on the board this way when I'm sitting at the bench. We need to look and see if that resistor is relevant. And then there's also R16 in between Q5 and Q4 and Q3, and we need to see if R16 is relevant, because maybe I just simply forgot to install these two parts and they were vandalized and ripped off the board, and that's keeping this circuit from working properly. So let's just start from the beginning where the tone signal comes in. It's going into this S112. There's a resistor pack that's going to be in place. Here is R16, and wouldn't you know it, R16 is one of the two resistors that is missing. So that should be 1K. I'll just write that down on my note. And when you take a look at this op-amp and what it's doing, notice how there's VCO, VC1, and VC2. This has got to be volume control for the entire audio circuit. That's what I think is happening here. And without R16 in place, this 1K, I think we're going to have no volume control for this tone section. Obviously, it has no effect on this whole speaker in section. That's separate. But this tone circuit isn't going to work properly without R16 in place. Now, if we keep going down the path, R13 feeds into the TL074. That goes through the actual amplifiers itself. There is no other resistors there except for R12, and that is in place on this board. R14, R15. I need to find what this R11 is. I don't see it in the amplification circuit unless I'm missing it. Luckily, it's searchable, and there is R11 up there. This has to do on the contrast latch. So this is the part of the board that actually is controlling the contrast of the CRT, because the Lisa does have software controllable contrast where you can have a screensaver where it like dims down the screen or, turns the brightness down on the screen. And I'm pretty sure that's happening via this contrast latch. So I think with that resistor missing, that part of the circuit wouldn't have worked. I never actually tried to hook a CRT up to the Lisa, so therefore I wouldn't have noticed that particular problem. And that would have become evident later when I tried to actually use the CRT. Yeah, that would have been a problem, I think. Okay, so R11's a 10K. I wrote that down on my note here, and the other one is a 1K. Very common values, luckily, so I need to get those installed into this board. And I suppose while I'm at it, I should probably look for any other resistors that might be missing. So those two are missing. What else did I miss? Because I obviously missed that. Everything's fine there. Everything is fine there. These are all in place. Same with those. Down here, we're all good. Capacitors. R41 is missing, by the way, but I validated against photos of other I/O boards from the Lisa 210, and R41 was not in place. I should still search for this on the schematic just in case. Maybe it should be there. I don't know. So let's see, R41, nothing. It's not on the schematic at all. What's handy is on the Wikipedia article for the Lisa, there aren't a whole lot of pictures of the inside of the computer, but there is a photo of the Lisa 210 I/O board because it has the IWM chip on it. And there's R41 and is not installed. There's R11 installed and there's R16 installed. So that just confirms that R41 is not supposed to be there, but these other two are. So I'm just clearing out the holes. I'm forgetting these components installed into the board. This is the 1K resistor for R16. I'm going to use this lead former, and I showed this very briefly when I was rebuilding this motherboard. And the nice thing about it is you can bend the legs to the exact right length. That way, when you put the component into the board, it's nice and centered, just like the rest of the parts. And I found the spacing that Apple used for things like resistors is the 0.5 on this little lead former. And there we have it, R16 and R11 reinstalled into the board. Now, when it comes to the speaker on the Lisa, this was the one from the Barn Find Lisa that Jared sent me, and I think this works, but clearly I don't want to use this one. Now I have this speaker, which I took out of a television set, and I guess my concern is that it might be too tall. I don't remember where the speaker goes exactly in the Lisa. Oh, I should probably take a look. It's 3.2 ohms, while this one was like 7 point something when I measured it. So it might be a bit louder, and I don't think there'll be any problem using a 4 ohm or 3.2 ohm speaker versus the original 8 ohm. I just took a look at the Lisa chassis and I don't actually see where the speaker goes. It might go onto the bottom of the floppy drive cage. There's a space that looks like it might be for a speaker. So I'm going to review my original triage video so I can try to figure out exactly where the speaker is because I don't exactly see it. Okay, so there's the bottom of the floppy drive cage and no speaker there. So I don't think that's not where it was, obviously. You know, looking at this reminds me of how much cleanup I still have to do on the chassis. I think it's all aluminium or aluminum. So that rust and crap there should come off, but I'm really gonna have to scrub the heck out of it to get a lot of that off. Oh, there it is. There's the speaker. It's under the CRT, oddly mounted at an angle, which is kind of funny, but actually makes sense because the little grill marks in the paper match the angle of that is there. So, okay, that's good to know. I need to go see if the speaker is going to fit. I know the mounting holes are in exactly the same spot, so that's not a problem. It's just the clearance that might be an issue. And this came out of a television set, so the magnet should be shielded, and we shouldn't have an issue with that. I just took a look at the computer, and there's no way to even test fit this without taking the CRT out, and it's currently mounted in the chassis. So therefore, I'm not going to use this one. I'm going to try to use something that's lower profile, just so there's no issues with clearance when I go to assemble the machine. And I just looked in my bin of speakers and I found this one. And this one looks like it's a much more suitable fit. This little harness was what was connected to this bad looking speaker. Pins are not corroded, so I think that's fine to use. Wires are connected. I'll just wipe this off. It's kind of dirty. The connector on the power supply harness is equivalently dirty. Let's just clean that off. It doesn't have to be perfect, just a little bit less bad. And all we need to do to see if this works is power up the Lisa without the floppy drive connected. And it's currently unplugged. And we'll get the error tone out of the speaker if all is working well. Here we go, 3, 2, 1. There it was. It beeped. All right, problem fixed. One more item off the list. All right, next problem on the list, the power light. So the switch has an integrated light, but I was told this comes apart relatively easily. There's some metal clips that you can pop this apart. On the backside where the switch is connected, there are 2 pins in the middle, and then we have 3 and 3. Those 3 aren't used, but these are. And typically this is probably going to be the switch contacts. So I wouldn't be surprised if one of these is connected all the time, and then when you push the button, the other one becomes connected. So we could test that pretty easily. So with the multimeter set to continuity mode, we have continuity there between those 2 pins, and we shouldn't between these 2, unless we push the button. And I'm pushing it down on the table, and it goes away. And this one here, when I push it down, like that, it goes away. So this is definitely our switch contacts. That means that this is the light bulb inside. It's going to be an incandescent light bulb, and I think incandescent light bulbs, when they're off, they should have relatively low resistance. So we should see something on these 2 pins for the light bulb. And I'm just pushing through the oxidation, and there's nothing, absolutely nothing. So either the light bulb is broken, or there's just bad, dirty contacts inside. And you can see how dirty the switch looks. So place your bets whether you think it's going to be dirty contacts inside or a burned out light bulb. So now to figure out how this comes apart, I don't think it's necessarily these metal parts. This would be for panel mounting this. You put a square hole and push this in and it will clip into place. And then to get it out, you have to kind of squeeze these together. The button probably pops out to reveal the light bulb inside. And it is not immediately apparent how this comes apart. So I'm going to do a little bit of research first. I don't want to go through another issue like I did with the disk drive where I took the hard road to take that thing apart. Here we are on LisaFac. This was a great resource last time I looked at it. The cap has 2 detents, one on the top and the bottom. Use a non-metallic tool such as a wooden tongue depressor to prevent gouging the plastic to pry the cap off. You may need to pry both sides at once. Well, that wasn't very helpful. Well, I just decided to try to pry it out a little bit. Oh, there it comes. Okay. Let's try to extract this little light bulb. I'll do this carefully, not to squeeze it too hard and break it. The fact that it has a silver coating inside just sort of screams that it wasn't just a bad contact. I think this was actually just open. So I bent the 2 little legs out that were over the glass, mega ohms. So that's just a bad bulb. Now the contacts inside don't look great either. So it could have easily been bad contacts. But you know what? I want to replace this with a warm white LED, and I think I can do it. So the contacts inside the switch require the thickness of this glass. So I'm thinking of taking pliers and just like breaking off the top part of the light bulb and attaching an LED directly onto the two contacts that go through the glass. That way I can push this back into the connector in there. And obviously I'll have to add a resistor. Now the one thing that does matter with an LED is the polarity. The light bulb that was originally in there, which you can see is a very similar size to the warm white LED, it doesn't care about polarity. So I need to figure out which is the ground pin of these two. So let's turn on the Lisa. I'll have to poke my finger in here to do it. All right, there it is, 5 volts. So that should be like a 460 ohm resistor would run that very nicely. And the negative is closest to this RLM side. Power is off. I'm just gonna put fresh solder on these kind of corroded joints there. And we're just gonna attach this LED as a test. Forward voltage of one of these warm white LEDs is something like, I don't know, 3 point something volts. All right, let's see what happens. I have a bag full of these, so if I cause it to go bye-bye, it doesn't really matter. Okay, here it is. Let's check the voltage on the LED. And there's the forward voltage, 2.944. According to the bag, 3.2 to 3.6 is the forward voltage, so we're under 3 volts. That means there's no problem. It's not overdriving that LED at all. And it would take the little cap. I guess one issue is it might have a little bit of a hot spot. So one trick that you can do is just put a little piece of tape over the LED, and then that diffuses the light a little bit. So it goes without saying, I'm gonna have to install this LED in line with the LED. So it can't be inside the switch, it's gotta be on the outside here. So I'll cut one of these traces and then bodge on the resistor on the back side, and then this will be LED equipped. But first thing I have to do is figure out how to get this LED mounted onto the light bulb. And that's what I would like to do, kind of simulate the light bulb. So I'm gonna put some safety goggles on. I'm gonna try to snap the light bulb off so I preserve this part, and I just want this part gone, the globe part. I think that worked. This is exactly what I wanted, because I'm gonna actually attach the LED to those two leads, because those go through the glass and then they're wrapped around. So then I can push this back into the little socket holder thing in there. Okay, so I used my engraving tool to kind of get the oxidation or whatever was on those leads off. And then I was able to solder the LED onto it. Hopefully the heat didn't damage it. Let's quickly test it. All right, so I cut the trace right there. This is the positive side. I'm gonna put the resistor from that pin to that pin. There we go. If anyone ever wants to put a light bulb back in here, all you have to do is just remove the resistor and reconnect that trace. As for this switch, I'm gonna add some of this Deoxit D100 down in there. It's been working without issue, but I'm gonna put a little bit on each of those contacts where the light bulb goes in, and hopefully that makes it down to the switch itself. Oh, that was a fail. It just immediately broke. Actually, you know what I need to do? I need to cut that white thing off, and I need to move the LED down a little bit because it was a little bit too high inside the switch body. I think the cover would have hit it. All right, there's the new shorter version, and I'm thinking I should probably get the hot glue gun out, put a bit of hot glue on there just to kind of give this some stability. The leads that were inside the original light bulb are very, very fragile. Okay, there we go. Just a little dab of hot glue gives this a little bit of stability now. And I have hot glue on my fingernail. All righty, let's see what happens here. It worked for a second and then stopped. It is not more reliable. I think we're dealing with bad contacts now. I put some D100 directly on the contacts. Okay, there it is, but it's flaky. All right, how's that gonna look with the button? We got a hot spot. It's hard to see in the camera, but I can see it, unfortunately. Okay, so I put some tape on the button. So it's gonna look like that while it's powered on, which I think is plenty good. We push the switch down, clip it into place. All right, here we go. Turn the power back on. LED conversion. Well, okay. Bit of a hot spot. Yeah, it's not exactly great. I don't know how the original switch looked, to be honest. It might have had a hot spot as well. But this one, yeah, it's got a bit of a hot spot. Oh well, I might try to figure out a better solution for that at some point in the future. Maybe I'll buy a original light bulb replacement, or perhaps I'll just get a diffused LED, maybe a square one, something like that, instead of the clear one that's on there now. The next thing I'd like to work on is I want to test out the other 2 RAM cards that Jared sent me. So I have a total of 3, even though the Lisa can only accommodate 2, total of 1 megabyte with the stock RAM cards. And I was thinking that the power on diagnostics, where it tests the memory card, it goes by really quickly and also doesn't tell you how much memory you have, how much was detected, although there might be a way in service mode to do that. So I thought maybe what I need to do is try out the diagnostic utility called LisaTest. This is a 2-disc set, and I found some screenshots online. It looks like this can do really thorough diagnostics, including burn-in diagnostics that take, well, overnight to run. Well, unfortunately, this is where I'm running into a little bit of a problem. I tried this LisaTest disk before, well, another disk. I made a few copies of it, and it doesn't seem to work on this system. I have the keyboard connected just in case that's required for LisaTest to start. So we'll power on the machine. It's nice to have a power LED that works. Oh, incidentally, I ordered some straw hat LEDs, which apparently are the widest beam. Therefore, if I put one of those inside the power switch, it won't have that really bad hotspot. All right, so no errors. Let's boot LisaTest. And what it does is it accesses the drive for a while, which I know works because I'm able to boot other stuff on this computer, like the Lisa OS or LOS Disk 1. And what this does is just runs for a little while like this, and then that's it. It stops. I let this sit here for a good amount of time, like 30 minutes, and there's no change. Now we do have a second disk, so if I pop this in the floppy drive, when it's stuck here at this screen, that doesn't do anything. So I'm going to push the reset button, and let's see what happens when this tries to boot up off this other disk. So it's accessing the floppy drive now, and when you hit 2, and there we go, error 38 immediately ejects this disk 2. So I don't think disk 2 is bootable. If I put disk 1 back in and I push continue, it will boot up and just get stuck in the exact same spot. So I decided to actually search for this problem, unlike what I did with the disk drive, and I found someone else who's saying the same thing: Lisa system hang when booting diagnostic image or disk. This particular user, and this is a post from 2021, they have 2 512K memory boards and both passed when they're in either slot. It says the device can boot MacWorks, which is the Macintosh operating system for the Lisa, or the Lisa Office boot disks, which is what I was doing before with that error message that we saw earlier, but it won't boot any diagnostics, either via real floppies or floppy email. And they tried LisaTest 3, LisaTest 2.2, although I have to admit, I downloaded both of those images and they have the exact same CRC. So the 3.0 copy that's floating around is actually exactly the same as the 2.2. Either way, I also tried a few of the other diagnostics like this burn-in diagnostics and Lisa 2 system diskette, and none of those work either. I think the burn-in diagnostic just brings up a white screen and then stops. And the user does say that the disk drive stops making noise and the Lisa will just hang on the screen with an hourglass. Verbose mode shows booting as in the screen below. Now, I'm not sure what this verbose mode is. I'm going to have to look this up. It appears that it actually shows some additional information, and maybe I need to figure out how to do this. Google was not much help on verbose mode, but I did find this Lisa handbook, and it seems that this came up at least when I had verbose mode, so maybe it's mentioned inside of this document. And unfortunately, that is not the case. Verbose is only found in this document once. There's a little bit on booting the system, and it does talk about how to go into service mode, Apple S, and also Apple II for continue booting or restart, power cycle, these various options that will pop up. And unfortunately, not really finding much else about Apple Lisa verbose mode. What about verbose boot? Yeah, unfortunately, not really finding anything useful. So the funny thing is this user does say that when they boot MacWorks, which is the Macintosh operating system, the Finder shows 512K whether one or both of the RAM boards are installed. It should show 512 or 1 megabyte. Other people on the forum go on to say that not being able to boot the LisaTest is not normal. It should work. And even on this configuration, it should be booting. One user suggests trying a couple little utilities, NeoWidEx and LisaMandelbrot. And these seem to be open source projects, where NeoWidEx apparently looks like it's a utility for working with the Widget hard drive. That's the internal hard drive on the Lisa 2/10. And the other utility is a Mandelbrot utility for the Lisa. It's a bare metal assembly program that plots the Mandelbrot set on the Lisa's display. So I went ahead and made floppies for both of those utilities. Let's see if these work on this machine. So first disk, I'm not sure which utility is which. I had to use my Macintosh Classic to make these floppies. All right, let's try booting. Oh, okay. Read 65 kilobytes. All right, so NeoWidEx, this does seem to be working. Obviously, I don't have a hard drive plugged in, so I can't really do anything. I don't know if this even works with the profile, but this is definitely working. Cool. Okay, so that utility works. Thanks for using NeoWidEx. All right, let's try this other disk. This is going to be the Mandelbrot one. So we hit restart. My concern is that this machine has a hardware problem that I just haven't seen yet. So start up from 2. Oh, disk ejected immediately. Oh, look, there we go. It's drawing the Mandelbrot. Bare metal. So this doesn't really rely on anything. And it just shows that we're able to load software from the disk. And that doesn't bode well for the fact that LisaTest is not working. Now, in case you're wondering, I did make this multiple times with multiple floppy disks. In fact, I formatted these disks first into Macintosh, single-sided, and then I wrote them using disk copy 4.2. So I'm very confident saying these disks work. In fact, I made these other disks with the exact same process. On this earlier post, it mentions that there's a way to actually see how much RAM the Lisa thinks it has by going into service mode and looking at 2A8. Which apparently is on page 27 of the manual for the LisaTest ROM. Let's see what we can find in here. And there it is, 2A8 total amount of memory. We can also see all sorts of other information, like the system type. Cool. Why don't we poke around and look at what we see here? All right, so you can see the Mandelbrot's still running. I think that's what it said it does. It runs infinitely. I'm going to stick in the LisaTest disk 2. That's going to cause an error when I actually reboot the system, and that'll allow me to get into service mode. Now, I'm pretty confident that the computer just thinks it's got 512K of RAM, but maybe that's not the case. Oh, I gotta actually boot the system to get an error. There we go, service mode. Okay, actually one of the issues is I can't look at my desktop and the video capture at the same time because I have just one screen to do both. So you're just gonna have to trust me on what we're doing here. So we're gonna do display memory, and I'm looking at 2A8. Okay, so this is telling us 0080000, that is 80,000 hex, which when you convert that to decimal is 524,288, which happens to be exactly 512K. If we divide that by 1,024, yes, 512 kilobytes. That is what the Lisa thinks it has now. What's interesting about this forum post is this user's having exactly the same issue as me, meaning things seem to work okay. It detects 512K RAM, but LisaTest freezes. Now, we go to the very end of this thread, and I've already read it down to the end. It turns out, and by the way, there's a whole bunch of corrosion. This user, because of the battery leakage, had to build a new motherboard from scratch. And back in 2021, there was no recreation that Alex had come up with yet. So this user created a new motherboard from scratch, it seemed like. And at the very end of the thread, they actually got LisaTest running on their machine. It's running off of a floppy emu. What was the problem? Well, it turns out that this was their own doing. They misread the hand-drawn semi-schematics for the motherboard and had botched pin 39 from memory 1 slot to pin 39 on memory 2 slot. So that basically the computer thought both cards were installed all the time. And at the end, they had 1 megabyte of RAM into Mac OS, where before they were only ever getting 512K. I wonder if somehow this is the same exact problem that I'm having. It would be weirdly coincidental. But I think one way to test is I should test out those 2 other RAM cards I got from Jared, see if they work individually in this machine. And then I should put 2 of them in at the same time, and we can look at the total RAM count that we did in the service mode to see if 1 meg of RAM is detected or it still thinks it's 512K. Because what if somehow this is an identical problem to what this user was having? So here are the 2 RAM cards that Jared sent. And I think the first thing I need to do is I need to clean these edge connectors. So it's my usual way with some deoxit and then some magic eraser. And this first one is the one that has some critter corrosion that the CPU board that from Jared also has. But I think the other RAM card doesn't have any. So this one might not work because of this corrosion, but the other one may be okay. This has the nice ceramic chips that have Apple logos on all of them. You can't see up here though, we do have some eaten traces. That was from the corrosion on the back side. So this might be a showstopper for this board. Not that it can't be fixed, but like the CPU board might be too much for it to work. Right, so first this is the RAM board that I tested with Alex that I've been running on the entire time. I'm gonna switch over to the one that I just cleaned, this one. And the RAM card I just installed, it went into slot 1. There are 2 slots, and as far as I'm aware, you can plug a card into either one if it's just one, and it will work, but it's in slot 1. Okay, this card doesn't work. So we got the double beep, which I think indicates the RAM error right off the bat, and the display buffer is held in the RAM card, and that's probably what's going on here. Service mode, can't get to it. So yeah, this is a bad card. Okay, so just like the CPU card, this card is not working, and I bet you we have some bad traces up here. In fact, yes, that looks pretty rough there. Not unfixable, but rough. Okay, here's that third card. This does not have any corrosion on it as far as I'm aware. Yeah, front and back looks good. I just need to clean this edge connector, which even after cleaning, there's definitely a little bit of corrosion on there. A little piece of magic eraser, at least on the front side. Yeah, that machine was just exposed to a lot of moisture. Right, so that third RAM board hasn't been installed. Here we go. It doesn't work either. Oh boy, both of them are bad. All right, so I have a thought. Maybe I put the good RAM board in slot 1, and then I put the bad RAM boards into slot 2, and then that should allow the diagnostics to display correctly. We can go into service mode and maybe try to figure out exactly which RAM chips are bad on that card. Well, both of the other cards that don't work. And actually, just thinking before I do that, what I'm going to do is I'm going to stick the working RAM card into slot 2 on its own. I just want to make sure the system does boot that way. Working RAM card is in slot 2. Here we go. Aha. Interesting. Very interesting. Well, I'm going to switch the known good card back into slot 1. Sorry, you can't see what I'm doing. I just don't have a way to record the top of the Lisa without blocking my view of the monitor here. So known good card is back in slot 1. And there we go. System is working. Right, so that's interesting. So I'm not sure if the RAM card that works should work in slot 2, because I know they're addressed separately, I'm pretty sure. So it's quite possible that it has to be in slot 1, the first card. And I'm going to take the card out, and I'm going to operate the system with the card lifted out entirely, because I want to see what the pattern on the screen looks like with no RAM installed. And that's currently what we have. No RAM card is in the Lisa right now. Ah, so doesn't this pattern look very much like this third RAM card, the one that has no corrosion, the flashing and everything? Yes, it does. Yes, it absolutely does. The known good card is back into slot 1 with just that card. There it is, system initialized without issue. Okay, so what I'm going to do now is I'm going to put in the third card, the one that doesn't have corrosion, into the second slot, and let's see if the computer can even see it or detect it at all. Okay, let's power the system up. No. So that second card corrupts the system and it's not able to run. So this is the one I just took out of the system that was causing that corruption. Third RAM card, no corrosion. It says Pepsi 88 in the corner for whatever reason. The brand of RAM that was on that card, by the way, is Texas Instruments. So it's not something like MT RAM that's known to go bad. And this card, the one that has the Apple logos and it has the corrosion up here on the back corner, it says Pepsi 88 as well. The RAM is all Hitachi brand. And I think the problem on this card is surely going to be those bad traces up here in this corner on both sides. But I'm going to try this in the machine in that second slot with the known good card in there. First, I'm just going to turn the system on, make sure it does boot properly. Yep, it's booting without issue. So it didn't break anything putting that bad card in. All right, so let's put this card in. All right, here we go, moment of truth. Let's see what happens. Ah, system posts at least. Is it going to detect 2 meg or 1 meg of RAM and get a RAM error? Well, this is taking longer, so that's a good sign. So it seems like it's seeing both cards, but is this, oh, everything passed? You get what? Total amount of memory is 2A8. Yeah, that worked. It sees 1 megabyte. So the way we can tell is this byte right here was an 8 before, 08, and now it's a 10. And if you convert all of this 0010, 0000 into decimal, that signifies 1024K. So that's very odd that that RAM card doesn't seem to work in the first slot, but in the second slot, it passes the diagnostics. I suppose what I should do is try booting LisaTest with 1 meg of RAM and just see if it is somehow happier. And I think without a doubt, I'm going to have to go onto this RAM card and really sand away the solder resists that are on those traces that are damaged and tin those and fix any weak traces that might be there. My assumption is it's just going to do exactly the same thing and not work. Maybe. Wait, this is going longer than it ever did. What? This works now? It doesn't make sense. Why does this work all of a sudden when it didn't with only 1 meg? Oh, this is super confusing. I wonder if it thinks that because this is a Lisa 210, I think all Lisa 210s had 1 meg of RAM. And is that the problem? Okay, well, I'm going to run the short test because it says it's going to take 40 minutes and we'll see what happens. All right, I'm back, and it's actually been sitting here for a good number of hours, actually. Met up with a friend and had dinner and stuff like that. And the test finished. I'm super confused as to why it wasn't working when only 512K was installed. Part of me wonders if I'm running into that issue where we have some slight incompatibility or differences between the Lisa 2/10 IO board along with the 2.5 motherboard that I'm using. And perhaps it's possible that LisaTest really only works on Lisa 210 IO boards if you have 1 meg of RAM installed. If there's anyone out there watching who has a 210 with a 2.5 motherboard and takes out one of your RAM cards, can you see if LisaTest works for you? Or is there actually something wrong with this computer? Because the results here are clear as day that the short test is passing perfectly, and that's with the corroded RAM card in there in the second slot. What's really strange to me is why doesn't that RAM card work in the primary slot? Maybe I just didn't have it seated properly. I'm gonna turn off the computer and, oh, it ejected itself, or the disk that is. It is turning off the Lisa. There we go, turn the computer off. So I think what I'm gonna do is I'm gonna pop out the known good memory card in the first slot, and I'm gonna put the card that's in slot 2 right now, that's the damaged one or the corroded one, and I'm gonna stick that into the primary slot and just see if the computer boots up with just 512K. Okay, so that's the card that was in slot 1, the one that's been working the whole time. Here's the card that was in slot 2. This is the one that's got the corrosion on the backside. I'm gonna put this into slot 1, and I'm gonna make sure that I have this seated correctly. The little latches on the Lisa that hold the cards in, they're a little fiddly, and I maybe didn't have it seated correctly the first time we tried. So let's power on the Lisa. Aha, it works. So I must not have had it seated correctly. I suppose what we can do is we can take this LisaTest disk 1, let's try to boot that with just 512K installed. And it stopped. Same problem. So it's not the RAM card. This has got to be a bug in LisaTest. It's just got to be. Now what I'd like to verify, because obviously I didn't have this card seated properly, I want to put the third RAM card in here and again make sure that's seated correctly. Because I think I'm finally getting the hang of using these little latches on these cards. Here's our third card. This is the one that when I had this in the machine, we had all that wild graphics and rolling image. All right, here we go. 3, 2, 1. No, okay. So I definitely had this third board in correctly. It was all the way seated and it is not working. And when this goes into the machine, of course, it sort of trashes the bus, which almost makes me think that some of the bus transceivers on this board might be bad. There's one more test I'd like to do because I'm not confident that my seating of the RAM cards into the slot was done correctly last time. So I put the corroded but working RAM card into slot 2 and it is definitely pushed in all the way. I'm going to turn on the machine. Oh, and it works. Well, it kind of works, but now we're getting a RAM error. I just kind of jiggled the card around in the slot a little bit. See if that made any difference. No, that made it worse. I just reseated the card one more time. Oh, this is very interesting. Quite interesting how we're getting these other random things. I'm moving the card in the slot a little bit and we're kind of losing connectivity. So perhaps this whole issue is just a connectivity issue. And you know what? Deoxit that socket. So there we go. Good deoxit on there. Let's see what that does. All right. Yeah, the deoxit in the socket. Okay, so we're still getting a RAM error 70. Now, is that just because it's unhappy, for instance, that I have no RAM card in the first slot? Maybe? It says MEM2 though, and that is the slot that's actually in there. So I'm gonna power this off and move the card around a little bit. So I just sort of jiggled it around in there. And now we're getting a 71. Very interesting, very interesting. Ooh, and there's some random dots. Okay, I reseated it. Now we're getting a CPU error. I'm not so sure about this RAM card, really. And after reseating it one more time, at least we're not getting the CPU error anymore. So, okay. So it had a tick mark for the RAM card, and then it's giving us this error. Is this just because it really can't work without a card in MEM1? Is that possible? And I just tried to go service mode, and now it's this rolling, which is odd. Why would it be rolling? I hit the reset button. Now it's not rolling. All right, so that very first card, the battery damaged one, is in slot 2. Look at that. Now you just saw that it didn't work at all. Oh, so strange. I mean, it's basically identical every time, which is so odd to me. So I just cut out a bunch more board swapping. I think I was in denial of what's actually going on here, and anyone watching probably realizes it as well. It seems that there's a problem with the second memory slot on this machine. It appears that if I put either of these working memory cards into slot 1, everything seems to be working fine with the machine, 512K, and there are no issues. But as soon as I try to put anything into that second slot, things go awry. Now, I managed to talk to Alex a little bit, and I wanted to clarify with the Lisa if you can use memory cards in either of the slots if you just have one card. And Alex confirmed that absolutely either of the slots can accommodate just one memory card. The memory management unit on the machine can remap the memory as necessary so that the system can work. And we're definitely having an issue where even my known good card, which is currently in slot 1 behind this one, if I put that into the second slot as the only card, the machine doesn't work at all. It's just garbled screen, which really points to the fact that the second slot is actually the problem. And this coincides with the fact that when I run both cards in there, we get instability and issues. So the fact I was able to run the LisaTest utility one time and actually complete the short test, I think that was just luck that the second slot was just making good contact at that point. I still have not been able to ascertain, and Alex wasn't sure, if LisaTest, when you're using an I/O board from a Lisa 210 like I am, if it can run with 512K. So that particular problem might not be a fault, and we might just be dealing with the same thing we had with the disk controller, where I did all that troubleshooting with the disk controller just to find out that this is just an idiosyncrasy of using the Lisa 210 I/O board in a 2.5 motherboard, that you have to have the little floppy adapter connected for that to work. Now, this is something I wasn't really able to show before. This is the second memory slot, the one that's labeled MEM2. And you'll see that this memory card is definitely seated all the way into that slot. In fact, if we turn it like this, I think that's pretty much in there all the way. And if I flip the tabs to pull the card out, it comes out of the slot without any issue. And then that reveals the second slot there, MEM1, with the battery damaged memory card inserted. And you can see that it's inserted exactly the same way. And I've never really had any problems with MEM1. It always seems to work properly with either of these cards. Now, this was a brand new slot that I installed into this board when I assembled the motherboard, and you can tell that it looks in good shape. All the contacts look perfect, and there really are no issues. Now, you might be thinking that maybe there's some problems on the bottom side when I soldered it in. Well, that's where I was able to go back to footage that I recorded during the assembly of the motherboard, and unfortunately, I didn't really show it super close up, but here is the MEM2 slot on the back side, and we can pretty much confirm that all of the joints are connected. I was thinking maybe I left a joint unsoldered and that was the problem, but everything looks really good there. And I took a couple stills from the video. The second one is this one, and you might look at this and say, oh, maybe there's a bridge solder joint there. Well, I think that's just the flux, because we look at this one and clearly it's not bridged. And actually this still came from the video after I was holding it at this angle. So it's really clear to me that all these connections are made and none of them are bridged, which unfortunately kind of leads me to believe that potentially the issue is that the slot itself is somehow bad. And I don't really get it. I put deoxit into it and it doesn't really seem to help the situation. And the working card from mem slot 1, if I put it in that slot on its own, it doesn't really boot at all the system. We get all sorts of weird errors. It's just got to be a bad connection somehow, but how? Especially when you look into the slot, it doesn't look like there's anything physically wrong with it. It just looks totally fine. So maybe what I'll do again is just do some card swapping, and I'm going to take the card, this is the working card, out of slot 1, and I'm going to pop this into slot 2, and you got to kind of twist that so it comes out all the way, because now I know from Alex that this card should work without any issue in this slot. So we'll just stick that into the slot like so, and the card is definitely in there. I can't pull it out because it's properly latched, both of these latches. And let's give this a test one more time, and maybe I'll just try some more deoxit in here and see if we can somehow finagle this to get it working properly. Yeah, the card is seated in there properly, absolutely properly. And here we go, let's turn this on, see what happens. It just doesn't work. It just does not work. So I'm just gonna cut out this section, but I'll spend a moment just jiggling the card around, moving it to one side or the other, see if I can get this to work in that second slot. So no amount of pushing and pulling that card in that slot could ever get it to work. It really never changed. It always looked like that same garbage, or maybe it was rolling with that same garbage. So I decided to take a look at the schematics. Unfortunately, I wasn't able to find schematics for the RAM card itself, but here are Alex's recreated schematics from the motherboard. And the memory board 1 and 2 connectors are all the same, except there's a few things. So pin 39 is some kind of a slot signal, and that's just left floating on memory slot 1, and it's grounded on the other slot. But the other thing is there are these extra signals S1 through 3, and those are hooked up on memory slot 1 to these pins T1 through T3, and on the second slot, those are left floating, and the S1 to S3 are connected on this side. So it's quite possible that there's bad trace or something's wrong with the card that is allowing it to work in memory slot 1, but not in 2. So I really need to check the differences, the pins that are different on this card itself, and just make sure that those signals find their way to appropriate chips and things like that. And what I do know for sure is that this board, this is the one with the corrosion on it, it kind of works in the second slot. It sometimes works, right? I got this actually working on there. Sometimes there was corrupt graphics and things like that, but it was mostly working. So at least I can compare these two cards together and try to find which pins on the schematic coincide to what fingers on the connector, and then trace them to the appropriate components, and then check to make sure that they make their way through on this other board. The worst thing about the problem I'm experiencing here is I still don't know if the problem is really on the motherboard or with the cards. Obviously, if I had access to another Lisa, I could just test these cards in that Lisa, in its second slot, and see if they work or not. But this is the kind of problems you have when you don't have two of them to just try to get to the bottom of where the issue is happening. So just to help me with this endeavor, I have drawn out the differences. So MEM1, pin 39 goes to whatever slot signal is there. And then we have ground, T1 or S1, it's labeled both ways, ground, S2, ground, and S3. And then on the MEM2, this 39 signal is actually grounded. And then we have S1, no connection, S2, no connection, S3, no connection. So I really need to figure out where all of these signals go, 39 and 51 through 56, and then I need to make sure they're all connected on both of these cards. And while we don't have pin numbers on the card itself, there is some on the motherboard, and I took a look at what it looks like when the card is inserted. This is pin 2 here, pin 1 is on the back side, and this is pin 60. So 59 is on the back side. Then that is pin 56, 54, and 52. These ones I have marked. Now what doesn't quite make sense to me is these ones are just connected to whatever that trace is, pin 58, which I just checked the schematics, pin 58 is ground, digital ground. And as a way just to double check that we are oriented correctly, pin 60 and 59, the one on the back side, should be 5 volts. And we can see that this rail goes over to this capacitor right here on that positive pin. And it is connected. And then of course this one is connected right there to the negative rail. So that kind of tells us that these are probably sense pins, and they might have something to do with it being able to sense exactly how large the memory card is, because we know that pin 52 and 54, which are these two, are just connected directly to ground. This one goes to something else, and I don't think it's going to go directly to 5 volts. This must go to something on the board. So I need to figure out what that is, and let's look on the other side, because it goes to that via. There it is there, and it goes up somewhere else. And when we look at this side of the board, we have 59, 57, this is ground, and then we have 55, 53, and 51, and those aren't connected to anything. And on the slot 1, those are just grounded. But oddly enough, when this card is stuck into the second slot, those are the sense pins. But yeah, 59, 57, 55, 53, and 51. And comparing it to the other card, those 3 pins aren't connected to anything either. And that pin looks very suspect right there, doesn't it? And on this side of the board, on the battery damage card, yeah, things look pretty much identical. And I had already checked that there is continuity between all the stuff here that I sanded off. And there absolutely was. So again, pin 39 is a slot signal. So whatever is on that pin, and it gets grounded when you put the card into the second slot. So it makes its way to that via, which unfortunately is directly under this freaking IC. Okay, well, what I want to do is I want to make sure that on the battery damaged one, this is making its way through. And it is. Okay, so that is not the problem. So pin 56, T2S3, goes to that pin on a resistor pack. So we flip this over. That's this resistor pack. There it is. That's the connection right there. So we can double check that on the other board. Yeah, there's that connection. So it's funny, I don't see any actual differences between these two cards. At least for these S signals, they seem exactly the same. Yeah, and these other 2 pins for those S signals, those are on the ground lead of that cap. So that's the same on both of these. And then on the back side, these pins 51, 53, and 55, which are those, not connected. Now to try to trace down where this pin goes, that's the pin 39, I'm going to use this. This is a brush, and it allows me to put the probe on that pin and then just touch around the board to try to figure out where it goes exactly. Okay, so we know that via is connected to that pin. So there it is. And we lost trace of this signal underneath. So you just kind of brush around, and unfortunately you can't just rub it because this is a metal brush and it hooks onto the pins. Okay, I just got a beep out of it. Aha, there it is up there. You can't see what I was seeing there, but this is the resistor pack again, somewhere up here. There it is. So back to the regular probe. So there it is. It's on that resistor pack, that same resistor pack that the other signal is hooked up to. So that way, if this signal gets grounded, it doesn't matter. So we can double check on this board. This is the one that doesn't seem to work when it's plugged into the other slot. And I know this is the via. And there we go. It is connected. Let's see what this resistor pack, what it measures. 1K per leg. So one side is all hooked up together on this trace, which I'm assuming is 5 volts. Yeah, it just goes to the 5 volt rail. So I'm on the positive side of one of these caps. Okay, so that tells us that the pin 39 on both of these cards is connected to 5 volts via a 1K resistor. Sorry, that's a little hard to read. And then 54 and 52 are hooked up directly to ground. And then to figure out these other signals again, so 55 we're looking for. So this is 59, 57, 55, not hooked up to anything. 53, not hooked up to anything. And then 51, not hooked up to anything. And incidentally, there is this one trace here that has sort of a bad looking joint right through there, but it is connected. Yeah, it's connected right to there. So that is good. So I don't really see any problems or any differences between these two boards that would account for this board totally not working in that second slot. Other than, of course, the slot on the board is somehow bad. I mean, that's the only thing I can really think makes sense. So maybe the last thing I need to do real quick is just polish all of these fingers on both of these cards, put deoxide on them, and just make sure, without a doubt, there's the best possible connection in that slot. Because obviously something is the matter. I just don't know what it is. So this is one of those fiberglass brushes here, and I'm just gonna brush this stuff. All right, that looks a little bit more shiny, a little better. I'll clean that with some alcohol and then add some deoxit to it after I finish the other board. You know, while scratching this away, I just had a thought. What if these signals that are picked up by maybe the CPU board, maybe they're not making it through to the CPU board? No, because one of the cards works in that second slot and the other one doesn't work at all. So that doesn't make sense. All right, I have a little deoxit on there, just as the final cleaning. Nothing too bad coming off there. And cleaning the second board. All right, so there are the two boards all cleaned up. If these don't work properly in the second slot, it's got to be the second slot that's bad or something on the motherboard that's bad. So I suppose I'm going to start with the battery damaged board on its own, and we're going to stick that in the second slot. And before I do that, I'm going to just add some extra deoxit into the slot itself, because who knows, maybe some junk got on these contacts. Lower the card down into the slot. It's in there. Okay, here we go. Let's see what happens. Wow. Okay, so that was weird. I tried to turn on the system and it just immediately shut down, which is odd because nothing is shorted out. Everything is connected properly. Let's try again. It just immediately turns off. Why? Okay, I just popped the RAM card out, so there's no RAM card in the system. Main power is on. Push the power button. No, same thing. Oh, you're kidding. What exactly did I do? Yeah, computer just turns on, immediately turns off instantly. It's back to that original behavior that it had when the power supply was acting up, which has me wondering if the little potentiometer on the side of the power supply somehow is flaky and maybe it's somehow gone up again and it's doing that shutdown thing because the voltage is out of spec. You know, I have to admit, everyone, that I thought this video was going to be super easy and I would do a few fixes. We'd plug the hard drive in, everything would be booting, computer would be working at this point. I did not expect to be having so many issues with the RAM boards, but now be back to the problem where the computer doesn't even turn on anymore. Okay, so I'm on the 5-volt rail. Computer's off right now. Let me turn it on. And I don't understand. The machine is just running. What is going on? I never actually touched anything on the power supply at all. I just connected the multimeter to the 5-volt rail on the I/O board. That's it. And I just reseated all 3 cards. So the RAM board is now in slot 2 again. I reseated the CPU and the I/O board. Okay. At least it's running now and we got a beep out of it. And we have 5 volts and it's a good stable 5.00, so it's not like it's running out of spec or anything. So why was it just turning off? I have no idea. But cleaning the card edge connector on the battery damaged card, that's card number 1 that's been working the whole time, in slot 2, we're still getting exactly the same fault here. Hit the reset button and yeah, same problem. I just took the card out and I'll stick in this card, the one that we've also cleaned. I'm gonna put this into slot 2 and we'll see if this works. All right, here we go. Is it gonna actually start? Yes. Oh, it doesn't work either. Looks very similar as well, doesn't it? It's not rolling. The pattern is a bit different, but it is just not happy. I am gonna reseat the CPU card just for fun. Nope. So now neither of these cards work at all in the second slot, at all. And I'm gonna move card 2, this is the one with a bit of critter damage on it with the ceramic chips, into slot 1. And let's see if the computer will post and not give us RAM errors with that card in the first slot. All right. Okay. Floppy drive is unplugged, which is why we're getting that error. So let's plug that in so we have everything connected again. All right, floppy drive is reconnected. We're at 4.9, whatever, 6 volts. Hey, at least it's actually running properly here. So just for fun, I'll put in LisaTest disks 1. I'm sure it's not gonna work, but just in case it decides to boot with 512K, maybe this will be the time, I don't know. Nope, it froze in exactly the same place. Okay, so that's card number 2 in slot 1. I'm gonna put card number 1, the first one, the battery damaged one, I'm gonna put this into slot 2, so we have 1 meg of RAM, hopefully, and let's see if the computer is even stable at all. All right, here we go. 4.98, no, it won't run. So freaking strange. And hitting reset would just get the double beep. I tell ya, I freaking tell ya, this is wild. Right, what I just did is I installed the original battery damage card in slot 1. Slot 2 doesn't have anything in it right now. This is the config I was running the whole time when we were initially doing testing with this thing. Let's see if this computer can even work. That looked weird. What was just, oh, you're kidding me. This doesn't work now. Unbelievable. The memory count thinks it's got 512K, but clearly we have corruption and stuff on this card now. So I think what's happened is all my messing around with the battery damaged card actually broke it. Seriously, what is happening? This is unfreaking believable. I guess this is what happens when all your cards are kind of sketchy and have corroded edges and whatnot on them. I just reseated the CPU card just in case it's somehow not connecting through properly to the RAM bus. No, it looks exactly the same. The lines look wrong. Yeah, oh, this card obviously failed. Something failed on this card. Unbelievable. And really the question is, do we have a bad RAM chip or do we just have a bad trace? It really feels like there's gonna be bad traces on this board, right? I mean, we got all the sorts of battery corrosion. It's gotta be that. At least the problem is consistent now. It's consistently bad. There's actually a way to figure out which RAM chip is bad using the service mode, which does work, luckily. LisaFac has a section on figuring out which chip is bad if you're getting memory error 70 or 71. When we look at this one particular memory location in service mode, it's gonna list out a bunch of bytes just like this, and in this one we have a 400 in that middle one. That says error in bit 14 in column 7. If the board is in mem1, the second word corresponds to row C. And then to decode this bit, there's a little table up here. So there it is. Bit number 14, column 7. So for my test results, I'm getting a 10 in that byte right there, hex 10. One board in slot mem1, that's going to be E. I'll just write this down. And since we're getting a 10, we got to go to this little table. So that's going to be bit 12 in column 5. Right, so when it's talking about the B, C, D, E, those are the letters there. So this is not the card that has the problem. It's the one that's in the computer right now, but it's row E, column 5. 5 is right there. This chip right there on the other card supposedly is the bad one. Now the issue is this is right in the corrosion zone. So I suppose I need to double check what's going on. Now the thing is these bits are going to be parallel between all of these chips. So if this weren't connected, all of these bits would be bad on these other banks as well. And the other thing is all the other lines except for the data bits are paralleled across all of these chips as well. So if we had a broken connection, then theoretically we would have other chips that were bad as well in that same bank, but it's pointing to just that single chip at E5 as being the problem, E5. Now just to see if the computer is definitely working, I took the card with the bad RAM chip out and I put in the other RAM chip into the first memory slot. Let's make sure everything is installed all the way. Yes, it is. Let's turn on the system. Yeah, this looks normal. That initial pattern that showed up when this one was in there, I saw like a bunch of dots that just look suspect. I have a feeling this one is going to pass with no issues. And it does indeed. So let's go to service mode. And absolutely all of those digits are 0. So that means no RAM errors whatsoever with this card. So there's our potential culprit. I didn't notice these Hitachi chips actually have Apple logos on them. I don't see anything out of the ordinary. The connection that's actually the data bit is that pin right there, the third down on that side. And I did double check and it is connected to all these other chips. So that's good. And because all the other signals are paralleled across these chips, if there were a break in one of these, then none of these other bits would be working. We would have tons of errors reported in this entire bank, not just a single chip. So it kind of leads me to believe that this chip has potentially gone bad. So I'm just going to swap that chip out. It's quicker than doing any other troubleshooting. We'll see if that fixes this board. There we go. New 64K bit chip is installed. There's the chip that I removed from the board. It was a little difficult. Some of the pins were very corroded from the battery damage. The RAM board with the new RAM chip is back in slot 1. Nothing else is in slot 2. Let's see if the computer works now. Oh no. No. Okay, so I got to start up at least, but the RAM card is not working. Oh, Oh boy. This is a never-ending set of problems here. Wait, I just reseated the card. Oh, maybe it's working now. I can't believe the number of problems I'm having. Oh, finally, finally. It finally freaking works. I wish I could run LisaTest on 512K and just let this kind of run through its diagnostics. Let's power the machine off and on. But there we go, turn back on. I mean, this is just totally ridiculous. So these were the bad parts so far that I've removed from the Lisa. I'm gonna put this RAM chip in here. If I do any testing with that chip, it'll be later. Because I obviously have much bigger issues with this machine. I mean, at least we're back to where we were, where one RAM card works in slot 1, and I'm sure LisaTest is just gonna run for a little bit and then freeze. And there it goes. It stopped loading. Great. Let me put this other RAM card into slot 2. The final test, let's just see what happens. With both the cards back in the system, we are where we were before when I was able to run LisaTest with 1 meg of RAM. What? No freaking way. Oh, I don't understand. I don't understand what's going on. This is so freaking strange. So this longer RAM test here, I think is it essentially testing 1 megabyte. So let me go into service mode and let's look up how much free memory there is. Display memory 2A8. Yes, it sees 1 megabyte. What's going on? I don't understand. I'm completely confused. I'm gonna shut the power off and I'm gonna jiggle the cards because I have a feeling this thing is gonna be completely unstable and not really work. I mean, it's still working now, but I'm fully expecting a RAM error. I mean, I just, and it doesn't look like I'm getting a RAM error. So I'm gonna pop in the LisaTest disk because I assume this is gonna work with 1 megabyte and then LisaTest is gonna load. Let's load off the disk. And all I can really think to do is run the long-term test with LisaTest if this does work and see if we're stable. I just feel like I can't trust this computer. And there it is, it just loaded. The reason why I feel I can't trust it is it just doesn't do what people say it should do. It can't run a memory card in slot 2 if there's nothing in slot 1. That doesn't seem to work. And then we have the oddities where this doesn't necessarily work as expected. So I'm gonna run the short test because I just want to see if I can get through that once. And if it can, then I suppose I'll do the long-term test. And I'm gonna skip the disk test. I don't need to test the disk drive. We know the disk drive is working properly. So we'll hit continue, continue, and one more continue for the external profile drive. There we go. Preparing to test the CPU board. Well, a bunch of time has passed, and the computer, it's sitting here running LisaTest. I think I've run this diagnostic, the short test, about 3 or 4 times, and the machine has not crashed, it has not skipped a beat, it has been working fine. Now, one thing I have to say is I really feel browbeat by this Apple Lisa right now. Just the problems keep coming. But while it is actually working, maybe it's time to take that profile hard drive and try to boot this machine into LOS. I want to make some progress here because I feel like I'm taking 2 steps forward and then 2 steps back. Like there's no forward progress being made. So I want to see this thing actually boot. So I'm gonna shut this machine off. Hopefully that gives me the disk out of the drive. Yes, it did. And I'm gonna grab the profile hard drive and a 25-pin cable, and let's see if we can get this thing to boot. So I don't have the actual cable for the profile hard drive, so I went and grabbed this zip disk SCSI cable, which as far as I'm aware is just a straight through 25-pin cable. So this should work. One thing to keep in mind, if you have a real Lisa that doesn't have a rebuilt motherboard, the 25-pin connector for the parallel port has one of the pins plugged. So you can't just use a normal cable without breaking the appropriate pin off. But since this machine has a standard D-sub connector that I installed just from my parts bin, it doesn't have that plug in it. So a regular cable like this will work. All right, there's everything spread on the bench, ready for testing. First things first, I need to turn on the profile hard drive, and I need to wait until the ready light becomes solid before I try to turn on the computer, that is. And the ready light is on. Took maybe like 45 seconds or so. Time to turn on the Lisa. Power switch is back here. Hey, it actually turned on and stayed on, and it's not corrupted looking. Let's see if the RAM check actually finishes or what's gonna happen. Okay. I can hear the profile doing stuff. Wait, the light is blinking. What? I figured it would ask me what it wanted me to boot off of. Okay, there was a low beep, but the light is blinking on the hard drive. Is this actually working? I mean, I really don't know. This is the first time I will have booted any Lisa up into Lisa OS. I saw it actually happening over at Alex's place when I was testing the CPU board. That was back in part 2. What? Rounded? Oh, look, Lisa Office System Release 2. I moved the camera up a little bit. Lisa Office System Release 2, 1983. That is what I loaded onto this profile hard drive. I am shocked. Absolutely shocked. Whoa. Yeah, of course the time is not set. There's no battery in this machine. Okay, well, clicking my first button in Lisa OS ever. There it is. There it freaking is. Monitor the printer. Set aside everything. Edit menu, okay. Housekeeping. Straighten up the icons. Eject the diskette. Wow, look at this. I still can't believe it. It's actually freaking working. I really, really can't believe it. Let me try double clicking on preferences. I don't want to spend too much time in here because that'll be for when I get the machine fully assembled. But this machine as, oh wow, what a strange preferences thing. It's so empty looking. Convenience settings. There's the monitor brightness or contrast level. That's what I had to fix using that. Well, there was a bad resistor, right? Or missing resistor. There's the built-in screensaver, the darkness level, the speaker volume. Let's check this out. Loud. Much louder, much softer, and silent. Flashes the menu bar. That works. And resizing a window on the Lisa for the first time ever. I guess you can't scroll the preferences because one of the items on the bottom disappeared. Wow. I can't freaking believe it. Set aside preferences. I guess that's how you close it. Ha! Well, there you go. This machine has put me through the ringer in this video, and yet there it is running LOS. It's actually working. And I assume that's with 1 megabyte of memory as well, which apparently makes it much faster. It's way slower, supposedly, if you only have 512K. So I think on this bombshell, I'm gonna end this video here. I can't help but laugh and almost feel like I wanna cry because my emotions feel like they're all over the place a little bit just because I'm just not convinced this machine is purely stable, but there it is, actually alive and running an operating system. Things that remain that are clearly problematic. There's something going on with the power supply. I know I need to change the cap on here. That's the safety cap across earth to the hot or live line because it did trip the breaker once, although it's been working fine here, not tripping the RCD or GFCI breaker. But besides that, of course, we have the problem where it doesn't turn on every time and I don't know what's going on. I really think it's the harness because it felt like when it wasn't working, as soon as I tilted the power supply this way, all of a sudden things started working. So maybe I just need to check those connections and maybe add some deoxit to the connector on the back here. I don't know what was going on, but I know that the thing was turning on and then turning off because I could hear the disk drive spin up and then it would just stop. So definitely was turning on and immediately turning off. So that is one issue. Then we have the whole instability thing with the RAM, and I just don't know if I touch anything on here, it's gonna completely break again. But maybe this is a stable configuration. What's the deal with me not being able to use the memory 2 slots on its own? I don't know. Everything I read says that you can do that and that should work, but clearly that doesn't work on this particular configuration. And then I have to say, what a weird oddity that one of the RAM chips just sort of failed on the battery damaged RAM board. Luckily that was easy enough to fix, and I'm glad the diagnostics that Apple engineers wrote is good enough to tell you exactly which chip is bad, so that's very helpful. I suppose all my handling of the board just somehow killed that one chip, I suppose. I don't know. Anyhow, I am happy at least I have some progress. I would have been pretty upset if I went through this whole ordeal with this machine in this episode and didn't even get any forward progress. So this is my forward progress, and I'm gonna definitely end the video now before something else breaks. In the next video, I have to hope that the machine is still working. That would be great. But then the next thing I obviously need to address is the CRT driver board, which is still back there plugged in and running right now. But I need to put that back together, get the horizontal output transistor into it, and hook that up to the CRT with the machine working, hopefully. And then we should be able to see if there's an image generated on that CRT and if it's dim or bad, like I think it's gonna be. And then we'll kind of go from there. And if testing the CRT works well, it doesn't really throw me a curveball, like it seems like everything has been on here, then perhaps I can finally try to fully reassemble the Lisa. I really, really want to see the Lisa back together with the working CRT, with the Mac Plus keyboard, even though it's not quite right, with the profile hard drive, with all this like beige stuff all put together. I want to see it actually working. That will make me feel so happy. And then once it's actually together and working, finally, then what I want to do is play around with and explore the operating system a little bit more. I'm going to refrain from doing anything more in this. In fact, I am just going to turn the computer off. I think if I push the power button, it should do a shutdown process, because I'm not going to do anything more. Yep, there we go. It's putting itself away because I want to explore on video and learn how to use this thing a little bit, because even though it looks Macintosh-like, it's definitely not a Macintosh. And some of the ways it does things are just different than we're used to. So there we go. That's it for this video. If you liked it, thumbs up. If you didn't, you know what to do. Huge thanks to my supporters. Subscribe if you haven't already done that. Comment down below. Seems that people are enjoying this Lisa series, and I certainly am enjoying it. This might be one of the biggest restorations I think I've ever done, although maybe not. I'm not quite sure about that. But either way, it's been absolutely a blast and a roller coaster of emotions with this darn machine. And I can't wait to play around with it some more. So that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.